So when we talk about a physical system, we begin with the kinematics. The kinematics is a description of the motion of a physical system. How does the object move through space? And in order to talk about the motion of an object, we first need to talk about the position of the object at any one instant. For example, the position of this marker can be up or down and can be at a different angle. So in order to begin talking about the motion of a physical system, we have to have some way of describing the motion. That description is called the kinematics of the physical system. And before we can even discuss motion, we need to discuss the position at any one instant. Take this marker. It could be up here or it could be down there. Those are two different positions. And it might be rotated, which also changes its position. So this idea of talking about the position of a physical system at some instant is known as discussing the configuration of the physical system. So let's give you some examples of configurations of physical systems. Maybe my favorite example is that of an elevator. So here's the ground, and the elevator is some way up, and here I am in the elevator. And this elevator can go up or down, and we want to have some way of describing the position of the elevator. So what's one way that we could describe it? Well, you know what floor it's on. But it might also be halfway up a floor or halfway down a floor. So if we want to be more exact, we might just talk about the height of the elevator off of the ground. So when Q is equal to 0, the elevator is at the bottom. And as Q increases, the elevator goes up. And in fact, we're going to use the letter Q in general to refer to the configuration of a system. So in this case, Q is just a real number. And if the elevator has a height limit, say 8, then Q is going to be a real number between 0 and 8. OK, now let's make things more interesting by adding another elevator next to it. So now we have two elevators in different elevators wells. And of course, and if that's me, maybe this is you right here. And of course, the elevators don't have to be at the same height. So let's describe the position of each elevator. Let's use Q1 for one of the elevators. And let's describe the other elevator by a height Q2. So now Q1 is going to be in the range of 0 to 8. And Q2 is going to be in the range of 0 to 8. But I might want to think of this pair of elevators as being one physical system. Not two separate systems, but one physical system. And so how do I describe the configuration of this entire physical system? Well, I need to describe the height of each of the elevators. So I can think of having a configuration vector. And sometimes when I need to remind you that something is a vector, I'm going to put a little underline underneath it. And this vector is going to have two components. It's going to have Q1 and Q2. So now, for example, let's try a little example. If my vector looks like 1, 2, then how do you read that? Well, you read that by saying that elevator number 1 is at height 1 off the ground, and elevator number 2 is at height 2 off the ground. Now, Q1 can go in the range of 0 to 8, and Q2 can go in the range of 0 to 8. So what's the valid range for this vector valued Q? Well, it's going to be the square of ranges from 0 to 8. So if I think of this axis as Q1, and I think of this axis as Q2, and this is the point 0, 0, this is going to be the point 8, 8. And so as Q1 increases, I move this way. As Q2 increases, I move that way. And so when the first elevator is at height 1 and the second elevator is at height 2, I can think of this as the point 1, 2 in my configuration space. And so this is the space of all possible configurations of the pair of elevators. And I'll use the big capital Q to call the space of all possible configurations of my configuration vector Q. Now, when we had a single elevator, we just had a Q that was a range of the real numbers. And when we added a second elevator, then we needed two numbers to describe our configuration. And so we now have this notion of dimensionality. When we have a single elevator and we need a single real number to describe our configuration, we say that we're in a one-dimensional configuration space. Whereas when we have two elevators and we need two numbers to describe our configuration, we say that we are in a two-dimensional configuration space. So in general, the dimension of the configuration space is going to be how many real numbers do you need to describe the configuration uniquely.